Hello, I'm Steve Miller. I'm a math professor at Williams College, and this is the next of the coronavirus lecture series. What I'm going to do today is do part 2 of our series on polynomials and applications. So today we're going to talk about quadratic equations. And these lectures are sponsored in part by the Journal of Number Theory and the Teachers as Scholars program. It's a pleasure to thank them for their support. What I want to do today is talk a little bit about what is a quadratic equation, what is it like, what does it mean, how do you understand it, how do you find where it has a zero, and then in the next lectures we'll see why we care about this. So right now this is a lecture that's going to be putting material in the bank. Okay, so a quadratic equation is of the form f of x is ax squared plus bx plus c. So a line or a linear equation had a polynomial where the highest degree of the variable x was degree 1, and then we had coefficients in front of the x and a constant term. Now we have a polynomial of degree 2. We have the highest degree is going to be x squared, and we'll have a coefficient a in front of that. Sometimes instead of writing f of x, we write y. Either one is fine. X and y is often convenient for the coordinate axes. F of x is our function. So for example, if I gave you 3x squared minus 5x plus 7, if we want to take x equals 2, so what would we do?
So we would plug 2 in
We would plug in 2 here, plug in 2 here. So we just get 3 times 2 squared minus 5 times 2 plus 7. And when the dust settles, you should get 9, assuming I haven't made a mistake. So a cubic would be a polynomial whose highest power is 3. Any idea what a quartic would be?
What?
A quartic polynomial. So quadratic is 2, cubic is 3, quartic is 4, quintic
5,
and so on. So how many points do you need to uniquely determine a line, and to uniquely determine quadratic? So before we did how many points were needed to determine a line, and we saw that there was 2 points needed. I want you to think now about how many points would be needed to determine a quadratic. All right, welcome back. And so how many points do we need to determine a quadratic?
3.
3 points. And so it seems like you need one more point than the degree. And if you think about it, we have 3 coefficients, A, B, and C. And if we have 3 points, that should give us some information to help determine what they are. So my question is, imagine I were to give you 3 values. So I give you 3 choices of x and 3 choices of y. How might you use this to then figure out what the values of A, B, and C are? So I will pause the video and give you a chance. And welcome back. And so the way you would find out these values is, well, if I give you 3 points, then for each value of y, you know what value of x it comes from. Just plug in the value of x here as before. So when we take 0, we would know a times 0 squared plus b times 0 plus c is 7. When we take 1, we would get a times 1 squared plus b times 1 plus c is 5. And similarly for the point 9, 2. Well, which one of these is the easiest to get information from?
The 7.
The 7, because we have 2 zeros, we immediately get 7 equals c. And then for the second one, we get 5 is a plus b plus c, but since c equals 7, we get negative 2 equals a plus b. And then similarly for the last one, we get 9 is 4a plus 2b plus 7, because we know what c is, we can, that should be c equals 7, we can get 4a plus 2b. We fix that. Okay, so we fixed the type, but let's just go back just to be safe. So when we put in 1, we have the 0.15, so when x is 1, y is 5. So we got 5 was a plus b plus c. We already know that c equals 7, so 5 is a plus b plus 7. Subtract 7 from both sides, and you get negative 2 is a plus b. For the last one, we have 9 is a times 2 squared plus b times 2 plus c. So 9 is 4a plus 2b plus 7, plus c, sorry. Since c is 7, we subtract and we get 2 is 4a plus 2b.
Yeah.
So we have 2 equations and 2 unknowns. How would we solve those?
Can't you just like add them together? No.
Well, if we added them together, is that what we would want to do, or do we want to do anything?
No, subtract them from each other.
Well, if we subtract them, what would we get? We would get 4a plus 2b minus a plus b. We would get 3a plus b.
Yeah.
So I don't think we
I
want to.
know.
What should we do before
multiply that one by 2. And
yeah,
then
multiply
subtract.
this by 2 and subtract, or multiply by negative 2 and add.
Yeah.
Either way. But we have 2 equations and 2 unknowns. So if we subtract 2 copies of the second from the first, I think I might have the order wrong. We would then get b's would cancel. I would get 6 equals 2a, or a equals 3. And since negative 2 is a plus b, we would get b is minus 2 minus a, so b is minus 5. Another way we could have done it is we could have used this equation, negative 2 is a plus b, to solve for b in terms of a. You get b is equal to negative 2 minus a, and then we could substitute that into the last equation. 2 is 4a plus 2b. We would get 2 is 4a plus 2, negative 2 minus a. We would get negative 4 minus 2a. So 4a minus 2a is 2a. Bring the negative 4 to the other side as a 4, and you get 6 equals 2a. And so again, we get 3. So there's two different ways we could do this. We could play games and multiply and combine, or we could solve for one in terms of the other and substitute. And really, that's what we did over here. And you can see why it's so nice to have 0 as one of your points. But 3 points uniquely determine a quadratic. So let's try to get a sense of what their plots look like. So a quadratic equation looks like this: ax squared plus bx plus c. What does the a do? So what's the difference between x squared, 2x squared, 4x squared, and negative x squared, negative 2x squared, and negative 4x squared? So I'll pause the video for a moment so you can think about what they do. All right, so what we did here is we actually took a piece of paper and we made a coordinate axis and we plotted a few points. We plotted 0, plus and minus 1, and plus and minus 2 for x. And we saw a shape kind of like this. Now, this one I went out much, much further, and you can see the growth rate. So here is x squared. Here's 2x squared. It's growing basically twice as fast. Here's 4x squared. It's growing 4 times as fast. So all of these positive ones are almost like upward U's. And as x gets very large, either positive or negative, x squared becomes very large. So it's going off to plus infinity in both directions. The negative ones are just reflected, and they'll be going off to negative infinity. So hopefully this kind of makes sense. Notice that we're starting with the simplest possible quadratic. B equals 0, C equals 0. We're just trying to figure out, what does A do to the shape of the quadratic? So the bigger the A is, the faster it's growing. So what does C do? So what's the difference between, oops, they should all be 2x squared, between 2x squared plus 1, and 2x squared minus 1. So I will pause the video and let you think about it. All right, so we've moved forward to try to get a sense of what C does, and we've looked at a couple of values. 2x squared minus 1, 2x squared plus 0, 2x squared plus 1. So what does C do?
It changes the y-intercept.
It changes the y-intercept. It's like your He-Man with a Hulk, or I guess, yeah, the Hulk people know. And you just,
the difference in
difference in how old you are. You just pick up the whole thing.
No, I was saying, like,
and this
how
is just,
heavy you are.
and how, right. And you're just picking up the whole graph and just moving it all up. Notice the curve is exactly the same shape. We're just sliding it up one. Right, now the last one is a little bit harder. What does the B do? So that's harder to see. Later, we're going to see that we can rewrite any quadratic as ax minus h squared plus d for some d. And the question is, what does this h do when we write it like this? So we've seen what a does. It just shifts things, changes the growth rate. D just shifts things up and down. So the question for you is, what does h do if we look at a couple of different choices? So we'll pause the video and give you a chance to think. All right, so here's a plot for a couple of values. So what did you just tell me it does?
It changes the position of it, like moves it sideways.
Yeah, it just moves it sideways. So over here, when I have x minus 2 squared plus 1, if x equals 4, that's the same as 2 squared plus 1. So x equals 4 over here is the same as x equals 0 over here. It just slides everything over. And what we're seeing here is, even though we might write the quadratic as ax squared plus bx plus c, if we want to plot it, it's much easier to plot it if we write it like this. If we write it like this, what does d do? Moves it up and down. What does h do? Moves it left and right. What does a do? It affects how rapidly it grows. And so frequently in math, there's more than one way to write things, and different ways will be more tractable than others. All right, so now we're going to go to trying to find, where does these parabolas, where do these quadratics hit the x-axis? Where do they hit 0? So we want to solve ax squared plus bx plus c equals 0. So before doing this general case, let's try a simpler quadratic. what's the simplest quadratic you can think of? What might its roots be? How many roots do you think it has? So I'm going to pause the video and give you a chance to think of what is the simplest quadratic and what are its roots. 2, 1. All right, so the suggestion I got from my assistant was just try y equals x squared. So take c equals 0, take b equals 0, take a to be 1. And that will be the simplest quadratic. So we want to solve when is x squared equals 0. The only solution is x equals 0. We're going to be a little careful here. We should really view this as a double root. We can write this as x times x equals 0, so 0 is occurring twice. A polynomial of degree 2 should have 2 roots, a polynomial of degree 3 should have 3 roots, and so on and so on and so on. So now, building on the success of y equals x squared, what do you think the next simplest quadratic to study is? To find where it might be 0. So I'm going to pause and let you think for a moment. So what we want to do now is we want to try to make the polynomial a little bit more complicated. And so what we're going to do is there's 2 natural choices. You could either put a coefficient in front of the x squared, look at ax squared, or you could add a constant c and look at x squared plus c. Well, if we have ax squared equals 0, we've already essentially done this. You divide by a, you get the double root of x equals 0. The other is a little bit more interesting. If x squared plus c equals 0, when does y equal 0? So I'm going to pause the video, give you a chance to think about this. All right, so our suggestion is how to solve this is my assistant has said we could subtract c from both sides and we get x squared equals negative c. So we could take the square root of both sides. But we have to be careful and we have to remember that when you take the square root, you could have a plus or a minus. So if I want the square root of 4, 2 and negative 2 both square root of 4. So for what values of c will this have an interesting solution? So can you give me a value of c where you can solve this without too much trouble?
4.
4?
Or negative.
Negative 4. Because then you would have x equals the square root of 4 or negative square root of 4. Can you give me another choice of c?
Negative 9.
Negative 9.
Negative
So
16.
if c is a negative square, this is easy. If c equals negative 3, you get the square root of 3 and negative square root of 3. You can do that, but which one is going to be really interesting? So I will pause the video and let you think about it. All right, so do you have a suggestion for value of c that might be troublesome?
1.
1. What would be the square root of negative 1? What
I.
numbers, yeah, glad you know it's I. You know, what number squares to a negative number? There's no real number that does it. Positive times positive is positive. Negative times negative is positive. 0 times 0, well, it's still 0, but it's definitely not negative.
But it's not positive.
It's not positive. Oh, sorry, it's not positive. There's no real number that squares to something negative. So if we take c equals 1, and if we try to solve x squared plus 1 equals 0, there's no real number that does it. So mathematicians have introduced a new number, I for imaginary, and we say I squared either is or am, depending on if you want to use good English, the square root of negative 1. And we will see later, although we won't be able to do a proof, that if you introduce just this one number, that is all you need to solve any polynomial of any degree. Just introducing the solution to x squared plus 1 gives you everything else. Absolutely amazing. So now we can try to combine these two cases. We could try to solve y equals ax squared plus c. So when would this equal to 0? So use what you've learned and try to figure that out right now. So we'll pause it. All right. So the suggestion was basically just repeat what you did before. So we have ax squared plus c equals 0. We first subtract c and we get ax squared equals negative c. Then we divide by a. We have x squared equals negative c over a. So this is essentially what we just did before. We take the square root and we find x is equal to the square root of negative c over a or negative the square root of negative c over a. So what could we study next? Well, the more general thing would be our general polynomial, ax squared plus bx plus c, and try to find where that is 0. We could, however, rather than writing it in this form, we could write in the other form we talked about, a x minus h squared plus c. So it's not in the same form as this, but we could solve this very easily, and we'll see that later we can reduce this general case, and we can always put something in this form into this form. So we just mirror the argument. We have a x minus h squared plus c equals 0. We subtract c. We divide by a. We take the square root and we find x minus h is the square root of minus c over a or negative square root of minus c over a. So to save time, so we don't have to keep writing these things, mathematicians have introduced the new symbol plus minus. It is a plus on top of a minus. And what this means is take whatever you have on the right and do it twice. Do it once with a positive sign and once with a negative sign. So this means we have two different solutions. X minus h is the positive square root of minus c over a, and x minus h is the negative square root of minus c over a. It's just shorthand notation for these two different things. And how should we solve for x? What do we do to solve for x?
Wait, what?
We have x minus h equals this. How would we find out what x equals?
Add h to the other
Yeah,
side.
just add h to the other side. So if we add h, we get h plus the square root of minus c over a, or h minus the square root of minus c over a. Or equivalently, h plus or minus the square root of minus c over a. So this means we have two different solutions, which is reasonable for quadratic. So what we did today is we said, what are quadratic equations? What do the coefficients mean in terms of their shape? How can we solve and how can we find the roots? And we were able to get up to a quadratic of the form ax minus h squared plus c. That's not the same as solving something like this yet, but maybe we could convert a polynomial like this to look like this. Mathematicians are lazy. Once you learn how to do something, you try to reduce anything that somebody gives you to what you already know. And once we can convert this to look like this, then we already know how to solve this and we'll be done. And so we will continue with that tomorrow. I hope you enjoyed today's lecture. Be well, be safe, go Sox.